All right. Well, how's everybody? We look excited to be back from our week-long vacation. Okay. Good news is we've only got 14 school days until you get a bigger vacation. So all you got to do is make it till December the 18th, that Thursday. You don't come that Friday. So 2.5 weeks, not too terrible. Too terrible. You don't come Friday. So the Thursday, the 18th is your last day. No, for as far as I know, it is a full day. They used to do a couple of half days, and then they started switching to just one half day. And then on this new calendar, it looks like the last day will just be a full normal day, and then we have a teacher work day on that Friday. Hopefully, we should be getting out. Once all of our stuff is taken care of, we should be free to go. But we have just a couple of things to take care of between now and then. So this week, we're going to be talking about systems of equations. So hopefully that's a little bit of a review for folks. If not, I can help you out with some of those strategies. But the plan today is we'll talk about systems during class. We should be able to finish that up tomorrow. I'll give you the assignment to look over. We'll talk about that on Wednesday. We'll have your quiz on Thursday, and then we should have just our class time on Friday to kind of kick back and relax at the end of the first week back. Now, going into next week, what's going to happen is I know that we switch every 2 weeks, and there's 3 weeks left in the semester, but you're going to be with me just till the end of the semester. Okay, so I won't even see the other group of students until the beginning of January. You won't see Mr. Schmidt until January. The reason is because next week, okay, we're going to have another full-length exam. We're going to give you a released PSAT. So you're going to be taking a module each day. So module 1 for English on Monday, module 2 for English on Tuesday, and then by Wednesday you'll get to module 1 math, and then we'll go all the way through that. So next week you'll definitely want to bring your charged Chromebooks to class. So we didn't mention this the first time around. Nobody mentioned it to me. I don't even know if you've realized it. That first exam we gave at the very beginning of the school year, everybody realized everybody just got a 100? Because it was just participation. It was right at the beginning of the school year. We wanted to go ahead and kind of get you accustomed to what the exam looked like. This one, that's not going to happen. Okay, not everybody's going to get a 100 unless you score perfect. So you're going to be working through the exams. You'll be putting your answers into some Google Forms, and then I'll be taking the grades off of those. So there will be a retake if you score less than you want to, but you definitely want to go ahead and get those done. But we'll talk more about it as we get closer to that. I do have paper copies, but I also have it on the Google form as well. You'll see the problem there as well. Okay, so you can do either. Okay, but I just wanted to go ahead and give you a heads up. But let's go ahead. Let's talk about some systems of equations. Okay. Now, for the most part, we're going to be talking about systems of linear equations. We will go ahead and kind of start to dabble into systems of nonlinear equations, but later in the notes. So if I have two straight lines, two linear functions, and I graph both of them in the same grid, there are 3 ways they can interact with each other. What's one? They what? They can intersect. Okay, this is typically what's going to be the most common case. So you could have 2 linear functions that intersect in one point. So that means you've got one solution. Because like any other system, you're trying to find all of the ordered pairs that are going to make both equations true at the same time. Okay, so this is case 1. They can intersect at a point. What's another one? They could never touch. What do we call that mathematically? They're parallel. Now, if the solution depends on ordered pairs that they share, what kind of solution would a parallel system have? No solution. Okay, it's very possible we might not be able to find an answer. And there's one other way they can interact. They can be the exact same line. So once you go ahead and graph one line, you might find that when you graph the second line, it's right on top of the previous one. Now, mathematically, we say these coincide. You know what you should do when it rains. Thank you. I appreciate that. So what's the solution here? A whole bunch. So mathematically, there's an infinite number of solutions. So what you're going to find as you're looking through this packet here, there's a whole bunch of review examples provided to you. Like, first thing it talks about, the 2 most common strategies used are going to be substitution and elimination. So I'm not going to go ahead and read this to you. I would encourage you to take a look at it, when you have a few minutes, because it's stuff that you're hopefully already familiar with. Okay, moves on to elimination here, gives you an example, and a lot of really good stuff here. But I want to go ahead and jump to this one that says no solutions. Okay, so I've highlighted this. A system of equations has no solutions when the two equations are the same except for their constants. Now, when we say constants, we're talking about those values that the equations equal. So typically, these are going to be in ax plus by equal to c form. Not every time. They might be in slope intercept or some other, and you might have to rearrange it. But anybody remind me what that form of a linear function is called? That is standard form. That is standard form. And there are restrictions on what we call pure standard form, but I don't think it's necessary that we get into those right now. So what we're looking at here, a system, we know immediately it's going to have no solutions if the x's have the same coefficient, the y's have the same coefficient, but it's the constants that are different. As long as they're different, there's not going to be a solution. Okay, so with that in mind, let's go to our first example. So negative ax minus 12y equals 15, 4x plus 3y equals a negative 2. If the system of equations above has no solution, what's the value of a? Now I can already tell that my two constants aren't the same. Does that mean that a would be negative 4? What am I missing here? Like, what do I need to do? There you go. See, the x coefficients have to be identical, the y coefficients have to be identical, and the constants have to be different. The only pair that I actually have are the coefficients on the y's. Those would have to be the same. So, I mean, I can go ahead and multiply through by a fraction, division, if you're willing to go that route. But we can go something easier here. What can I multiply a 3 by to ensure I get a negative 12? Negative 4. So let's go ahead and multiply that second equation through by negative 4. Okay, so the top one I left alone, so negative ax minus 12y is equal to 15. So now if I quadruple this, this is a negative 16x minus 12y is equal to a positive 8. Okay, so here is what should be happening. Because I rewrote it so that the y's have the same coefficient and I have different constants, well, that must mean that the x coefficients are going to be the same as well. And you could create a little equation if you want to. You could probably just go ahead and tell me what that was. But if I take a negative a and set it equal to a negative 16, that immediately tells me that a is 16. Good. Okay, question. Okay. Well, we have another little part here. An infinite number of solutions. So a system of equations has infinitely many solutions when both equations are the same. So what that means is we have to have the same coefficients on the x, the same coefficients on the y, and the same constants. Now, if you're looking at that equation, remember there can be scalars that make it look like they're different lines, but if we multiply or divide through, we can easily see that, yeah, they're identical to each other. Okay, so let's try number 2. 3x minus 5y equals 8. Mx minus ny is equal to 32. In the system of equations above, m and n are constants. If the system has an infinite number of solutions, what is m plus n? Okay. Well, can I immediately say that m is 3 and n is 5 and just say the answer is 8? No? Eric, what am I missing? We got to ensure that they're identical to each other. So the only pair that I know for sure, I know the constants are 8 and 32. So I got to make those the same. So I could just multiply the top equation by what? 4. If you're feeling a little ambitious and you want to go fractional, you could divide that second equation by 4 and multiply by 1/4. Okay, you'd be working with fractions, but you're still going to get the same answer. Let's see what I'm going to get. This would give me 12x minus 20y is equal to 32. And we didn't do anything to the second equation. Mx minus ny is equal to 32 now. So now that those constants are identical, I know that Those x coefficients should match up, as well as should those y coefficients. Okay. So James, what's m? M's 12. Okay. And Kylan, what's n? 20. Okay. Is everybody okay why it's not negative 20? Does anybody want me to show that? Okay. So what's my final answer? Remember, they wanted m plus n. So 12 plus 20, there's 32. Okay, question. It's not too bad, right? Systems. Okay, well, let's get to one of everybody's favorite word problems. Okay, so a group of 30 students ordered lunch from a restaurant. Each student gets either a burger or a salad. The price of a burger is $5 and the price of a salad is $6. If the group spent a total of $162, how many students ordered burgers? So it's not enough to solve the system. We've got to write the system before we go ahead and solve it. So I always like to do it this way. When you're working with a word problem, first identify the variables you're going to work with. Okay? Here we're talking about burgers and what? Salad. Okay? So let us see what variables you want to use. So let us see salads. Wow, it's the first day back. All right. So what would you like me to use for the number of burgers? X. So let's say X is the number of burgers. So I'm guessing the number of salads is going to be Y. Okay. So given my information, we know that how many students are there? 30. And each student either got a burger or a salad. So there's my first equation. I could say that the number of burgers plus the number of salads should equal up to 30, the number of students that we got. Okay. But now the other equation, I'm going to have to incorporate what? Okay, the price. So how much is a burger? $5. So it's $5 times the number of burgers that were sold plus what? 6Y, $6 per salad. And it looks like for the 30 students, the bill was 162. Okay. Now, we're just interested in finding X or Y. X. All I want is X. We don't need to finish the entire system. I mean, we could. And that's the thing. Sometimes they'll ask for an actual ordered pair. Sometimes they'll ask you to perform some kind of operation with the X and the Y that you find. Okay, it could be anything on the SAT or even the PSAT. So how would you like to solve this one? Substitution or elimination? I kind of prefer elimination. Okay. Well, since we're going to go ahead and solve for X, I would probably eliminate what? Let's eliminate Y. So I'm going to go ahead and multiply the top equation by what? Okay. Now here's the thing. When you're using elimination, you're either going to add or you're going to subtract the two equations. Okay. So if I'm choosing to multiply through by 6, that's going to give me 6x plus 6y is equal to 180. 30 times 6. Second one I didn't do anything to, 5x plus 6y is equal to 162. Okay. Now, if I go ahead and make sure that the coefficients are identical, and I'm using elimination, we're going to have to subtract. Now, if I had decided to go ahead and multiply through by a -6, if I'd made the coefficients opposites, then I would have added those. So it depends on how you decide to solve the problem. So in this case here, the 6y minus 6y is gone. 6x minus 5x, there's the 1x we're looking for. So how many burgers are we sold? 18. 18 burgers. There we go. Questions? Okay. Cool. Let's move on to more complex systems. So this is what I was referring to when I said a system of nonlinear equations. So if x comma y is a solution to the system of equations above, and y is greater than 0, so they're telling me that y is positive, what's the value of y? Okay, now for this one, if it's nonlinear, substitution is probably going to be your best bet. So let's rewrite this first one. Let's say y is equal to a -3x. Everybody agree I just rewrote that first equation? So now I'm going to take that negative 3x, and I'm going to go ahead and substitute it into the other equation. Okay. So let's see, x squared plus 2y squared. So that's 2 times, we now have negative 3x squared equals 76. Okay. So by substitution, I've got an equation in the same variable, and I can go ahead and solve for it. Okay. So let's see. So what is the quantity negative 3x squared going to give? Okay, 9x squared. So this right here is going to be a 9x squared. So times 2 would be an 18x squared. So it looks like I'm getting 19x squared total. Is everybody okay? Does anybody need me to show the steps, or are we okay with that? Anybody want me to write it out? Yeah. Okay. 19x squared is equal to 76. And now it just becomes a standard equation. Let's divide through by the 19. Okay. So x squared equals 4. There we go. So how do I get rid of the square? Got to take the square root. Okay, so x is equal to plus or minus 2. There we go. Now, that's not the solution because it wants what? We want y, but we want it to be the positive y. Okay, so I would just take this right here because we already have y equals. So let's see, y equals, if I take the negative 3 times the positive 2, that's going to give me a negative 6. Y is equal to a negative 3 times the negative 2. That's going to give me positive 6. And because it specifically said positive, that is what I'm looking for. Is everybody okay on that? Easy, right? Anybody having a hard time? Okay. Now let's try this one. So we got this system. It says if xy is a solution to the equation above, what's a possible value for, and what does it mean when we have the bars on the other side like that? Absolute value of y. There we go. Now here's the thing. This goes to show that these questions are going to be created in a specific way. If you notice something, that usually means it's a clue or a hint that can make your life a whole lot easier. Okay. Now, you'll notice in the second equation, both of these ratios is 1 over x plus 2, right? Okay. Let's go ahead and take this first equation right here, xy plus 2y is equal to 2. And let's say I want to go ahead and solve that for y. So how am I going to make those two y's a single y? Because I don't have like terms. We can factor it out. We can pretend that y is a GCF, right? So that's going to give me y times what? X plus 2 is equal to 2. Now when I go ahead and divide through, we got y equals 2 over x plus 2. Now the ratio that compares here is 1 over x plus 2, but those are really, really close to each other. Okay, that can't be a coincidence. So what we're going to use here is substitution to make this a lot easier. Okay, see, I already know that y equals 2 over x plus 2. Well, in order to make 2 over x plus 2 look like one of these, why don't I just do this? What if I multiply both sides by a half? Because what are these two's going to do? They're going to cancel. So this is going to give me that y over 2 is equal to 1 over x plus 2. So now I can use substitution. I'm going to go ahead and replace both of these here with y over 2. So this is going to be y over 2 squared plus y over 2 minus 6 is equal to 0. Now, I know what you're probably saying. Well, that's still got fractions. It's still going to be, messy to work with. Well, let me show you. What would y over 2 quantity squared be? y squared over 4. Y squared over 4 plus y over 2 minus 6 is equal to 0. Now let's say I don't want to work with those fractions. Okay, what's the one number I can multiply by that removes both of those denominators? 4. Okay, so that's going to give me y squared plus 4 times y over 2. 2y minus, don't forget to distribute across the whole thing, minus 24 is equal to 0. How nice does that look? And there might be someone out there who's thinking, you went through a lot of work to get that, and you're right, we did. Okay, but remember, are there always going to be different ways, more than one way to work these problems? Yeah. Okay, it depends on what you want to do. Now let's just factor it. Let's see, chart. I need two numbers that'll multiply to give me a negative 24, but those same two numbers have to add to give me a positive 2. Well, we got a negative, so definitely one of those is negative. What's that? Negative 6 and 4? Okay. Would that work? Negative 6 times 4 is a negative 24, but what's negative 6 plus 4? Negative 2. So what do we got to do? Switch those. There we go. Okay, so that's great. I was able to factor it. How does that help me, though? Yeah. Remember, we're going to set each one of these groups equal to 0 and solve. So just like Eric said, we're going to be taking the opposite. Anybody remember what we call that? A zero product property. That's exactly right. We were just doing that recently when we were solving trig equations. And my Algebra 2 students hopefully will remember that. So I'm getting y equals a negative 6 and y equals 4. Now this is one of those problems where there's multiple answers. So I'm coming back up here. It says, what's a possible value for the absolute value? Well, the absolute value of a negative 6 is 6. What's the absolute value of 4? 4. So this one has two possible solutions. It could be 6 or 4. Either one of those would work. How are we doing? Was it worth the wait? All that time over with Schmidt and English and then coming back over here after the break. Like, whew, I should have missed math. Okay, moving on. All right, example 6. If xy equals 8, xz equals 5, and yz equals 10, what is a possible positive value of xyz? Okay, so you're probably thinking to yourself, Mr. West, I got this, I can do it. Okay, let me give you about a minute to come up with that answer for me. Okay, let me get my timer out here. So we're given 3 definitions, and we're looking for x, y, z. So for this one, you would have gotten 2 answers, but you wanted the positive one. Show of hands. Who thinks they got it? Okay. Sean, what you got? It was 20. Okay. How many folks got 20? Okay. Good, good. All right. Well, let's talk about it. So they gave me 3 definitions, right? Okay. They're so excited to get to math class. What can I say? All right. So they give me these three definitions here, xy, xz, and yz. Now, we're looking for xyz. So maybe if I do something with these, I could end up with that. So what if I did this? xy times xz times yz. Okay. Think back to our exponent rules. X times x would be x squared. Y times y is y squared. Z times z is z squared. Okay. Now, I've got x squared, y squared, z squared, but I'm wanting x, y, z. What can I easily do to that? Just take the square root. Okay. But let's figure out what this should equal. Okay, so xy was 8. Xz is 5. Yz is 10. So I need an 8 times 5 times 10. 400. So if I'm looking for xyz, I'll take the square root of each of these. Now, xyz would have equaled plus or minus 20, but it said specifically we want the positive, which is why we just said positive 20. Okay. Question. Okay. Then the next part here, it kind of talks about what I started the lesson with, the fact that we're only going to have one solution, no solutions, or an infinite number. So again, take a look at that when you have the opportunity. Good stuff, good stuff. Okay, let's get to number 8. So y equals x squared minus 5x plus 6, y equals x plus 1. The system of equations above is graphed in the xy plane. If the ordered pair xy represents an intersection point of the graphs of the two equations, what is one possible value of y? Okay. Well, anybody notice something I could just immediately do and start to solve this problem? What did both equations equal? Yeah, substitution. See, they both equal the same variable, so if they both equal y, I can set them equal to each other. I can say that x plus 1 equals x squared minus 5x plus 6. Okay. And then we go ahead and do a little bit of cleanup here. Let's go ahead and remove everything from the left side. So the x squared is going to stay the same. Negative 5x minus x, that's a negative 6x. And then I got a 6 minus 1, so that's going to be a plus 5. Is everybody okay with what I've done? Well, this is another simple trinomial. What two numbers will multiply to give me a positive 5, but add to give me a negative 6? So 0 is equal to, let's go back to blue. 0 is equal to x minus 1, x minus 5. Okay. Negative 1 times negative 5, negative 1 plus negative 5. Okay. Zero product property. We're going to set each one of these equal to 0, just like we did a moment ago. So if x minus 1 equals 0, x equals 1. If x minus 5 equals 0, x equals 5. Okay, but always be mindful about what they want. Did they want x? What did they want? What is one possible value of y? Now, I could plug these x's into either equation, but I would go ahead and plug it in the easier one, make your life simple. So the first one would be y equals, if I replace x plus 1, that'd be 1 plus 1, so I've got a 2. Or y equals x plus 1, 5 plus 1, we're looking at 6. So either of those two values would be the solution you're looking for. I just realized, did I accidentally skip them? I did. I did, number 7. Oh. It's the dark entity. Oh, next door, sir. Okay. All right, so actually this one here, since I accidentally skipped over it, well, it's the same idea as the one we were just looking at. Because both these linear functions equal y, I can set them equal to each other. So 3x minus 5 is equal to a negative 2x plus 10. Okay. Now, they did go ahead and change this right here. I'll go ahead and mention this. Because they're using x and y, your answer would be the ordered pair x, y, right? They're just changing the variables from x, y to hk. So if they're asking about k, well, really that just means they want the y value. Okay. So we did one just like this a moment ago. Would you like me to work through it, or should I just go ahead and give you the answer? Okay. So the answer should be 4. Okay. So if you were to take a look through that. Now, remember, this would solve for x, but you want the y value. Okay. All right. So now let's see if we can get back on track. So example 9. There did 8. Okay. So we have y squared equals x plus 3, and y equals the absolute value of x. So a system of two equations and their graphs in the xy plane are shown above. How many solutions does the system have? Now, I could absolutely go ahead and solve this by hand, but if I have the graph already, how do I know what constitutes a solution? Where they intersect. That's exactly right. So the parabola and this absolute value, they intersect in 2 locations. So whatever they are, they would just have 2 solutions. We don't have to find those. Unless anybody wanted to. Just for the fun of it. Okay. And with that, we are now done. There we go. There's systems of equations. Okay. Cool.